In 1906, three men in Wisconsin built an engine in a garage. 109 years later, the President of the United States stood on their factory floor and called it a model American factory. 20 months after that, the factory was shut down and the jobs were shipped to Canada. That's the story of Waukesha Engine, and it's a story about what America does to the things it builds. The company started the way a lot of great American companies started, in a garage, specifically the Blue Front Garage on North Street in Waukesha, Wisconsin. Harry Levon Horning and Frederick Ahrens ran a motor car repair shop there. Horning came from a long line of Dutch industrialists. His father Henry ran a hardware store on Clinton Street. Harry studied engineering, worked on the Duluth Superior Aerial Lift Bridge, and somewhere in there developed an obsession with internal combustion engines. Ahrens was born in Germany around 1872, came to America at 11, and ended up working alongside Horning at the Modern Steel Structural Company. They became friends. They shared an obsession. And that obsession played out after hours, in the garage, on customer cars. Here's what they did. After the repair shop closed for the day, Horning and Ahrens would take apart engines that customers had left for service, not to fix them, to study them. They'd strip an engine down to the last bolt, examine every valve seat, every bearing surface, every combustion chamber wall, catalog what worked and what didn't, and then reassemble the whole thing before the owner came back in the morning. Night after night. Engine after engine. This was technically unauthorized research conducted on other people's property. It was also the most thorough engine education available in Wisconsin in 1905. They decided they could build something better. They needed money. They found a retired farmer named Allen Stebbins who had both money and an appetite for risk. On May 29, 1906, they incorporated the Waukesha Motor Company with a total capitalization of $25,000. Stebbins became president because he wrote the biggest check. Ahrens became vice president and superintendent of works. Horning, the actual engineering genius, got secretary-treasurer. Their first engine was the Model A, a four-cylinder unit that cost $12,000 to develop. They sold it for $500 to a man who wanted to power a boat on nearby Pewaukee Lake. That's a loss of $11,500 on their first sale. Not exactly a profit model, but the engine started easily and ran reliably, which in 1906 was not something you could take for granted. Word spread around the lakes. Orders came in, first for boats, then automobiles, then trucks. In 1908, the Chicago Fire Department bought a Waukesha engine from the Harder Auto Truck Company. It was the beginning of Chicago's conversion from horses to motorized fire equipment. 2 years from midnight garage experiments to powering the fire trucks of America's second largest city. We dig into stories like this every week. Engines, factories, the companies that built America, and the decisions that dismantled them. If that sounds like your kind of thing and you haven't subscribed yet, go ahead. Now back to Waukesha. The founders didn't stick around long. Stebbins left the company in 1908. Ahrens departed in 1910. The company was reorganized and recapitalized, with a businessman named Conrad Hertel elected president and Horning hired as general manager. A new plant was built on St. Paul Avenue in 1910, and that address would define the company for the next century. Horning was the constant. He'd eventually become president in 1925 and hold the position until his death in January 1936. Under his leadership, Waukesha didn't just build engines, it chased every market that needed one. The timing was extraordinary. World War I created a global food crisis. The Turkish Navy blockaded the Dardanelles, cutting off Russian wheat from reaching Europe. European farms couldn't produce enough on their own. American farmers were told to fill the gap, but the Army had taken their horses and their sons. They needed machines, tractors, and tractors needed engines. Waukesha had them. In 1917, Horning was named chairman of the Engine Design Committee for the Army's Class B military truck. The company produced the first standardized gasoline truck engine for military vehicles. The first of these engines was built and shipped to President Wilson's attention in Washington in just 11 days. 11 days from order to delivery during a war. By 1921, there were 169 tractor manufacturers in America building 232 different models. 78% of them used four-cylinder internal combustion engines. A huge number of those engines came from Waukesha. The company wasn't building tractors, it was building the hearts that went inside them. International Harvester was a major customer. At one point, IH placed an order for 10,000 Waukesha XA engines in a single batch. That's the kind of volume that keeps a factory humming. And when the agricultural depression of the early 20s killed most of those tractor companies, Waukesha survived because it was never married to a single market. Tractors collapsed. Fine. Trucks needed engines. Construction equipment needed engines. Oil rigs in the booming East Texas fields needed engines. Waukesha pivoted. In 1927 and 28, a stock International Harvester 3/4-ton delivery truck powered by a Waukesha XA engine became the first commercial truck driven across equatorial Africa from east to west. The truck was then sold to an explorer who drove it across the Sahara Desert, 6,600 miles in 35 days, averaging 15 miles per gallon. The engine never missed a beat. Its low oil consumption was, according to the expedition report, a perpetual wonderment to both adventurers. That's what Waukesha engines did. They just ran. In 1923, Horning secured the American rights to the Ricardo combustion chamber. This was a British invention by Sir Harry Ricardo that introduced controlled turbulence into the combustion process. The Ricardo head created a pocket over the valves where the fuel mixture would swirl during combustion, burning faster and more completely. More horsepower from the same displacement, less fuel consumption, less detonation. Horning marketed it aggressively, Waukesha Ricardo head engines. They sold retrofit kits so you could upgrade your existing engine with the new head design. By 1935, the product catalog was staggering. 120 engine models, 4-cylinder, 6-cylinder, gasoline, diesel, natural gas, kerosene, ethanol. If it burned, Waukesha had an engine that could run on it. One engine deserves special mention, the Hesselman. Designed by Swedish inventor Jonas Hesselman. This was a low-compression, fuel-injected, spark-ignited, multi-fuel engine that Waukesha built from 1932 onward. It could run on gasoline, kerosene, crude oil, natural gas, practically anything combustible. In a world where fuel quality varied wildly between regions, an engine that didn't care what you fed it was revolutionary. The Hesselman's success was directly tied to the unavailability of quality fuel in remote parts of the world. When World War II improved global fuel distribution, the Hesselman gave way to conventional diesel designs. But the multi-fuel philosophy stayed with Waukesha forever. It was part of the company's identity. Meanwhile, Waukesha wasn't just building engines for other people's machines. In 1935, the company introduced the Waukesha refrigerator, a gas-powered cooling unit for homes not connected to power lines. In 1936, they designed a propane-fueled air conditioning unit that mounted underneath railroad passenger cars. Before that, rail car cooling relied on steam from the locomotive. Waukesha gave each car its own independent cooling system. This led to refrigerated boxcars, refrigerated trucks, and industrial cooling units, all powered by Waukesha engines. The railway division used the compact ICK and Model FC engines, and these little units kept food cold and passengers comfortable across the American rail network for decades. But the most important thing Harry Horning ever did had nothing to do with a specific engine model. It had to do with every engine, every car, every gas station, every drop of fuel sold anywhere on Earth. In the 1920s, a serious problem was emerging. Engines were getting more powerful, but gasoline quality was wildly inconsistent. One fill-up ran smooth. The next one knocked the engine apart. Nobody had a reliable way to measure fuel quality. There was no standard, no number, no universal system. The Cooperative Fuel Research Committee formed in 1922 to address this. Representatives from the government, oil producers, and engine manufacturers. Horning was a key member. In 1924, he hired Arthur Pope as chief research engineer. Their task was clear: design an engine that could measure the anti-knock quality of gasoline in a standardized, repeatable way. Pope's solution was elegant: a single-cylinder test engine with a variable compression ratio. You could change the compression while the engine was running, which meant you could compare how different fuels behaved under identical conditions. Raise the compression until the fuel knocks. Record the ratio. Compare it against reference fuels with known properties. That comparison produces a number. That number is the octane rating. The CFR committee approved the concept in late 1928 and told Horning to build a prototype for the January 1929 meeting of the Society of Automotive Engineers. 45 days. Horning handed the project to Chief Engineer James Fisher, who along with Pope and a small team of machinists designed, built, and delivered a working engine in just over 6 weeks. One team member, Howard Wiles, took the original prototype home when he retired. He later returned it, and it sits in the museum to this day. They delivered on time. It worked. By 1931, the complete system was established: standardized test engine, reference fuels, rating scale, uniform procedure. The octane number existed. In 1980, the American Society of Mechanical Engineers designated the CFR engine as a historic mechanical engineering landmark. It later received the first international landmark recognition for global impact. Every time you see those numbers at the gas pump, 87, 89, 93, that rating was determined by a descendant of the machine Waukesha built in 45 days. Waukesha was the sole authorized manufacturer. They shipped thousands of CFR engines worldwide. The design principles from 1928 remain the foundation of the current testing equipment. Nearly 100 years later, still the global standard. Then came the war. When fighting broke out in Europe, Waukesha's order book exploded overnight. The plant went to 24-hour operation, 7 days a week. They built the F-817 gasoline engine for tank retrievers and heavy military trucks. They built the ICK for portable generators. They machined and assembled aircraft engines for the Navy. They built 2-cylinder air-cooled engines for the Crossley, a small car that sold for $325 through hardware stores. 5,000 Crossley engines were produced before the government halted civilian auto production, and those engines continued serving as military auxiliary power units. They powered winches for barrage balloons. They powered portable air compressors for inflating aircraft tires. At peak wartime production, the workforce reached 2,000. The majority were women, trained as machinists in jobs previously held exclusively by men. The plant was remodeled to provide them facilities. Barracks were built across the street to house workers pulling constant shifts. An entire auxiliary building on Elizabeth Street was acquired to handle overflow. By 1941, over 500 employees were commuting from outside the city, a new phenomenon for a plant where most workers had previously walked to work. 20% of the city of Waukesha depended on the motor works, 1 in 5 people. After the war, Horning was gone. He'd died in January 1936, but the man he'd groomed to succeed him, J.E. DeLong, carried the vision forward. DeLong had a background that reads like a folk tale. He'd run a steam engine, clerked in a store, and operated a village telephone switchboard before scraping together enough for Purdue. He paid his way through college by running a boarding house and doing laundry. After serving in World War I, he worked as production manager for the Indiana Truck Company before Horning personally recruited him to Waukesha. DeLong understood manufacturing at a gut level, and he understood that the post-war oil boom was about to create massive demand for bigger engines. The oil fields were drilling deeper. Deeper wells meant higher pressures, longer drill strings, heavier equipment. All of it required more horsepower. Waukesha delivered. In 1949, they introduced the 6LRZ, 6 cylinders, bore and stroke of 9.375 by 8.5 inches, 3,520 cubic inches of displacement. For context, a big modern pickup truck engine displaces about 376 cubic inches. The Waukesha was nearly 10 times that size. That same year, the 6LRD went into production, their first diesel in that displacement class, using the Ricardo pre-combustion chamber that Horning had licensed from Britain 25 years earlier. The technology just kept paying dividends. In 1954, they went bigger still. The VLRO AV12. 8.5-inch bore, 8.5-inch stroke, 5,788 cubic inches. Double the cylinders, double the horsepower. This engine was the direct ancestor of the VHP series, the family that would define industrial gas compression for the next half-century. The letters VHP were supposed to stand for Very High Performance, but the V actually came from the word Viscount. An advertising manager in the 1960s liked the sound of it. There's a footnote worth mentioning. The VHP family was originally going to be designated VC. A different family of high-speed engines was supposed to get the VHP name, but the vice president of marketing decided to switch the designations. The engineering was meticulous. The naming was office politics. By 1967, the 12-cylinder engines were extensively redesigned. Open-chamber diesel technology, 4-valve heads, angle-split serrated connecting rods, strengthened crankcases, new manifolding. Then the 6-cylinder engines got the same treatment. The entire VHP family was rebuilt using proven features from the V12 program. By the late 60s and into the 70s, these were among the most sophisticated large-bore gas engines anywhere. They ran 24 hours a day in the most demanding environments on Earth: pipeline compressor stations in the Canadian wilderness, remote power generation in Southeast Asia, oil fields from Texas to Thailand. The Unocal gas storage facility in British Columbia became the northernmost Waukesha installation, with 7 engines operating through extreme temperature swings, 8,000 hours a year of continuous operation. Minimum. That's driving a car at highway speed for 500,000 miles a year. Every year, the engines just ran. At its peak in 1965, not counting engines from its acquired companies Climax and Leroy, Waukesha was building 14 basic engine sizes. The application list was absurd: trucks, buses, tractors, cranes, shovels, drag lines, cement mixers, rock crushers, air compressors, gas compressors, generator sets, marine vessels, railroad equipment, oil drilling, mining, logging, cotton ginning, construction equipment, military vehicles, and the CFR testing engines. If it needed power, Waukesha probably made an engine for it. Now, the ownership changes. This is where the story turns. 1968. Waukesha Motor Company merged with the Bangor Ponta Corporation, a conglomerate that owned boat makers, firearms manufacturers, agricultural equipment. It didn't understand engines the way Waukesha understood engines, and critically, it couldn't fund the capital improvements the plant needed to stay competitive. The factory on St. Paul Avenue was aging, equipment needed replacing, tooling needed modernizing. Bangor Punta looked at the investment required and blinked. In 1974, they sold to Dresser Industries. Waukesha became the Waukesha Engine division, not a company anymore, a division, a line item. Dresser brought capital and stability. A major plant renovation was announced in October 1975. New high-rise warehouse, new machinery wing, modernization throughout the facility. The plan had 5 phases. During the renovation, the assembly lines were realigned from the north-south axis they'd used since 1909 to a more efficient east-west direction. A computerized part system was introduced. When a part was manufactured, it was assigned a tracking number and stored in the new automated warehouse. This was real investment, the kind that keeps a factory alive. But it was also turbulent. In January 1976, workers were temporarily laid off when expected orders didn't materialize. By October, 320 workers and 60 managers were let go. The plant shut down for 2 full weeks in November. The company president resigned in February 1977 at 53 years old. His replacement, Chet Lee, had an unusual path to the job. He'd had a brief stint at Waukesha in the early 70s, then supervised the construction of a Chrysler plant in Tehran, Iran. When Dresser brought him back, he held a series of open meetings at the Waukesha County Expo Center to introduce himself. The workers responded. Optimism returned. Lee oversaw the completion of the renovation and brought new energy to the company. Then the bottom dropped out. The early 1980s recession hammered construction and agriculture. When oil prices collapsed, thousands of drilling operations shut down. One day in 1982, Lee walked into the sales department and found 0 orders booked. Not a slow day. 0. With all their distributors, all their contacts worldwide, not a single person wanted to buy a Waukesha engine that day, or on quite a few days after that. By mid-1983, employment at the St. Paul Avenue plant fell below 600. Lower than any year since 1917, including the depths of the Great Depression. The workforce would recover to 1,200 by 1986, then drift below 1,000 by the mid-90s and stay there. In 1998, Halliburton acquired Dresser. Waukesha became part of the Halliburton Dresser Equipment Group. In 2001, investors bought the equipment group for roughly $1.55 billion and formed a new Dresser Incorporated. In 2010, General Electric bought Dresser for $3 billion. Waukesha was now a brand, inside a division, inside GE Energy, 4 owners in 42 years. Each acquisition pushed the decisions further from St. Paul Avenue. Each new parent had its own priorities. The engineers kept engineering. The machinists kept building. But the people who decided whether the plant lived or died were in Houston or Hartford or Boston. But the engines kept mattering. When the World Trade Center was built in the early 70s, 5 Waukesha Feed 12 diesel generators were installed in sub-basement 6, the lowest level of Tower 1. A 6th was added later, 1,200 kilowatts each, cooling water from the Hudson River. February 26, 1993. Truck bomb in the parking garage. The Waukesha generators activated. They ran for 3 hours and 10 seconds. The generator room flooded. Service personnel stayed with the engines until the water was dangerously high, then felt their way out in total darkness. September 11, 2001. The generators came on one last time. Emergency lighting, fire pumps, elevators. In early footage, lights are visible in parts of the complex as the towers fall. Those lights came from engines built on St. Paul Avenue. When Tower 1 collapsed, the generators were buried. 3 destroyed. 2 recovered and rebuilt. 1 shipped home to Waukesha in 2002. It received something close to a hero's welcome at the factory. It now sits in the Historical Society collection. 2 blocks away, the Federal Reserve Bank's 4 Waukesha generators ran for 2 straight weeks after the attack. A crew stayed with them around the clock the entire time. The engines also provided backup power for the Apollo space missions. Farms to moonshots to the worst day in modern American history. That's Waukesha's range. None of it saved the factory. January 20th, 2014. President Obama visited the plant, gave a speech on the factory floor about raising the minimum wage, toured the production line, called it a model of American manufacturing. The workers were proud. Their president in their factory. September 28, 2015. GE announced the closure. Manufacturing moving to Welland, Ontario. GE blamed Congress for the Export-Import Bank lapse. Canada offered major incentives. The workers were skeptical. A state representative called GE's spokesperson, who admitted the decision was already made and irreversible, then, in the same conversation, offered to help draft a press release blaming Congress. 350 floor jobs gone. GE kept 200 white-collar engineering positions. Jeff Neibauer, 25 years at the plant, said it simply. They cut out one piece of your heart at a time. They move jobs out. They move equipment out. They clear space and turn it into stock rooms. Scott Schmidt, 44, thought he'd worked there his whole life. Joe Acker, a veteran, was about to lose his position. The welding department dispatcher worried about losing his house. Most jobs in the area paid $15 an hour or less. He was making nearly $30. GE called the Canadian plant a brilliant factory. By April 2019, the Waukesha plant was closed. 236 final jobs eliminated. The machines went quiet on St. Paul Avenue. The brand exists. Ineo Group owns it now. Advent International acquired GE's distributed power business for $3.25 billion in 2018. Manufacturing happens in Welland, Ontario. Engineering remains in Waukesha, in what's left of the St. Paul Avenue facility. The Waukesha Engine Historical Society, formed in 1992 by former employees who refused to let the story disappear, maintains a museum on site. Ron Long was the first president. Members like Clifford Borgstrom, Rocky Schaefer, and Dennis Tollefson have spent decades cataloging photographs, engine specifications, and the stories of the people who built them. Over 31,000 Waukesha engines have been produced in the brand's history. 25 gigawatts of combined power capacity. Current models produce between 335 and 5,000 horsepower on natural gas. The largest modern Waukesha, the 18 V220GL, weighs 41 tons. It was developed using technology rights acquired from the Finnish company Wartime. The VHP series, descended from those 1950s oil-field engines, remains the industry standard for gas compression. The CFR octane testing engine from 1928 is still the globally specified instrument for fuel certification. In 2023, the Waukesha County Historical Society erected a marker at the CFR engine's facility, acknowledging the invention that changed the world's relationship with fuel. Both technologies survived because the engineering was that good. In 1906, it cost $12,000 to build the first engine, and they sold it for $500. That is a terrible financial decision. It is also the decision of people who believe the product mattered more than the margin. That belief carried the company through 2 world wars, the Great Depression, the agricultural collapse, the oil crash, and a century of change. What it couldn't survive was the financial engineering that came later, the buyouts, the conglomerate flips, the corporate logic that sees a factory as a line on a spreadsheet and labor as a cost to optimize. The engines survive. The engineering survives. The people who built them got a severance package, and the factory floor where the president celebrated American manufacturing is quiet now. They don't erase companies like Waukesha because the companies fail. They erase them because someone runs the numbers and decides they can be built cheaper somewhere else. And there you have it, Waukesha Engine. Built motors in the same Wisconsin town for 113 years. powered lake boats, farm tractors, fire trucks, military vehicles, railroad cars, oil rigs, the World Trade Center, and the Apollo missions. Invented the way the world measures fuel, and then got moved to Canada for a tax incentive. If you know something I missed, or your family worked at the motor works, tell me about it in the comments. And if you made it this far, subscribe. More coming next week.